We are still in section 1-6, but now we are going to be solving absolute value inequalities as opposed to absolute value equations. There are two types of absolute value equations, or inequalities, I'm sorry. The first part is the absolute value is less than B. So if you emphasize the word less than is an and inequality. So that means both have to be true. So the other type of absolute value inequality is the absolute value is greater than B. So again, if you emphasize greater, it sounds like or, so therefore either have to be true. So let's look at our first example. The absolute value of 3x minus 4 is less than 8. So again, if you emphasize the less than, it should remind you that this is an and inequality, so both need to be true. So your first step needs to be to ask yourself, is my absolute value bars all by itself? Yes, there's nothing being multiplied, divided, added, or subtracted to it, so I can change my absolute value bars to parentheses. And then I can distribute my two signs. So when I distribute my positive, remember it does not change anything. And then when I distribute my negative, it switches both signs. And remember, it does nothing to your inequality, and it does nothing to what's on the right-hand side. So now let's solve both separately. So I'm going to start with my one on the left. I'm going to add 4 to both sides. So that gives me 3x is less than 12. To get rid of my 3, I divide by 3, which gives me x is less than 4. Move on to the one on the right, so I'm going to subtract 4 this time. So that gives me negative 3x is less than 4. And don't forget, when you divide by a negative number, it switches your inequality. So you get x is greater than negative 4 thirds. I'm going to write my word and in the middle so I don't forget that it is an and problem. And let's go ahead and let's graph this. So 0, 4 gets an open circle because it's just less than. And 0 is less than 4, so I would shade everything to the left-hand side. Graph negative 4 thirds. It's just greater than, so it also gets an open circle. 0 is greater than negative 4 thirds, so I shade everything to the right. So in this region right here, is both inequalities true? No. In the middle, is both inequalities true? Yes. And then on the right-hand side, are both inequalities true? No. So just in between negative 4 thirds and 4 should be colored in. Now let's write our answer in interval notation. So remember, negative infinity is on the left-hand side, positive infinity is on the right-hand side. The first part of my graph where both inequalities are true, not both, not both, not both, here's my first part. So I write negative 4 thirds and it gets a parentheses because it's not a colored in dot. And then both true, both true, both true, both true, and then they stop both being true at positive 4. Again, it also gets a parentheses since it doesn't have a colored in dot. Press pause right now and I want you to solve for example 2. Then check your answer. The first thing you need to ask yourself is my absolute value bars by itself? And I hope that you noticed that they are not all by itself because of this minus 5 that's at the end. So let's start by getting our bars by itself. So we are going to start by adding 5 to both sides. And then that gives me the absolute value of 2x plus 2 is less than 20. Now, since they're all by itself, I can change it to my parentheses. And now let's make our two equations. So distribute the positive, it shouldn't change anything. Distribute the negative. So now let's solve for x. We're going to start on our left-hand side, subtract 2. So 2x should be less than 18. And then we're going to divide both sides by 2. And you get x is less than 9. Now let's move on to the right-hand side. I'm going to start by adding 2. So negative 2x is less than 22. And then I have to get rid of my negative 2. Again, since I'm dividing by a negative number, it needs to change the way our inequality is pointing. And I get negative 11. Let's draw a graph and write it in interval notation. So 0, 9 gets an open circle. Where is it less than 9? Everywhere to the left-hand side. And then where 11 should get an open circle, because just greater than, everywhere to the right is going to be greater than 11. And again, if you forgot in the beginning, we started with a less than problem, so this should be an and inequality. So I need to make both of them true. In the middle, both of them should be true. And your interval notation should be from negative 11 to 9 with parentheses around both sides. Let's look at example 3. If you notice, we are now talking about greater, which if we emphasize the end, it reminds us that this is an or problem. So the first thing we need to do is see if our absolute value bars are all by itself, which it is. So I can change it to plus minus and my parentheses. Now let's distribute the positive. It should not change my equation at all. I get 5x plus 10 is greater than 15. Distribute the negative, it gives me negative 5x minus 10 is greater than 15. So let's start with the left-hand side. We're going to subtract 10. So that gives me 5x is greater than 5. I'm going to divide both sides by 5, and that gives me x is greater than 1. Now let's move on to the inequality on the right-hand side. Start by adding 10 to both sides. So negative 5x is greater than 25. To get rid of my minus 5, I need to divide both sides by negative 5. And since I'm dividing by a negative number, it is going to switch the way the inequality is pointing. So now, since it's greater, it's an or problem. Let's draw ourselves a graph. 1 should get an open circle because it's just greater, and then everywhere to the right of 1 is greater. And then negative 5 should also get an open circle, and then it's x is less than negative 5, everywhere to the left is less than. And then it has to make either one true, so you shade like so. Now let's write our answer in interval notation. So we start on the left-hand side, and in this region, at least one of my inequalities is true. So it's from negative infinity to negative 5 with a parenthesis since it's an open circle. Then remember, when you jump from negative 5 to positive 1, you have to use the U for union to join both parts. And then either one is true starting at 1, so we're going to go from 1 with a parenthesis to infinity. Press pause, and I want you to solve example 4 and then check to make sure you got the right answer. Graph and write it in interval notation. So the first thing you should be asking yourself is, are my absolute value bars by themselves? If you notice, there's a plus 3 at the end and a 2 in front, so we have to move those first. So we're going to start by subtracting 3. So that gives me 2 times the absolute value bars of x minus 3 is greater than or equal to 10. And then to get rid of the 2, we divide both sides by 2. So that gives us the absolute value of x minus 3 is greater than or equal to 5. Now, since my absolute value bars are all by itself, I write my positive and my negative. And now let's distribute those so we have our two equations. So I have x minus 3 is greater than or equal to 5. Negative x plus 3 is greater than or equal to 5. So solve the one on the right first. Add 3 to both sides. So that gives me x is greater than or equal to 8. And then subtract 3. So negative x is greater than or equal, and then 5 minus 3 gives me 2. Now divide both sides by negative 1, and that gives me x, again switch your sign, and then negative 2. So on our number line over here, I have 0. Positive 8 is going to get a colored in dot because it's greater than or equal to, and then everywhere to the right is greater than 8. And then negative 2 also gets a colored in dot because it's equal to. Where is it less than negative 2? Everywhere over here on the left-hand side. And remember, it's grade tour, so it's either or is true. So now let's write our answer in interval notation. We start on the left-hand side. It starts from negative infinity, and it goes to negative 2. And negative 2 should get a bracket since it's greater than or equal to. And then union, because we jumped, again, 8 gets a bracket, and then it's not going to stop until it gets to positive infinity, and remember, infinities always get parentheses.